Hello everyone, Mr. Murphy here. Just gonna show you a video and a slideshow about how to compare rates of change for different functions. So you guys have been working really hard this week on slope, and we appreciate that. And this lesson is a continuation of what you've learned so far this week. So let me walk you through this presentation. Okay, so rate of change, and we're going to compare it across different forms. So we're going to look at tables, graphs, equations, all that stuff. Okay, here's what you're going to get out of this presentation. First, we're going to learn what is rate of change. And then I'm going to show you an example. I'm going to work through a problem and show you how to solve a similar problem. And then for practice, you have two problems that you need to submit on Canvas. And there is an expectation with these problems that you show all your work, and you also write at least a couple complete sentences explaining your work as well. So that's all explained on this screen. Okay, first off, what is rate of change? Well, rate of change describes how one variable changes in relation to another variable. If the relationship is linear, which it will be in today's classwork, the rate of change will be constant. It is helpful in a linear relationship to know that the rate of change is the same as the slope. Okay, so here's your first example. The directions say rank the following functions by rate of change from least to greatest. Show all work and explain your reasoning for each function. Okay, so we have three different functions, function A, function B, function C, and one's a table, one's a graph, and one's an equation. And so we have to use our lessons from this week, how to find slope on a graph and how to find slope on a table. And for slope in an equation, it's the coefficient of x, so it's right here. So I made a quick video solving this problem. So watch this video. Hi, students, Mr. Murphy here. I'm going to show you how to solve example 1 on my presentation. Okay, so we're here at function A, and the question is, what is the rate of change? So earlier this week, we learned that rate of change on a table is the ratio change in y over change in x. So I'm going to show from here to here, my change in y is plus 2. So that would be a change in y of 2. And then I find my change in x, and that is also plus 2. So 2 over 2. And it can be a little tricky on this table. So I'll show you the other changes as well. This change in y from 1 to 5 is plus 4, and this is plus 1. And I look at my change in x's. In this moment of time, the change is plus 4, and here it's plus 1. So when I fill in these ratios, at this moment it's 4 over 4 for my second interval. And my last one is 1 over 1. So I see all these different ratios, and I can see that all these ratios simplify to 1. So the expectation on these problems is you show your work like I have here, but you also explain it. So my sentence to explain it, give at least 2 sentences. I would say the rate of change for function A is 1. I know this because I use the change in y over change in x ratio. Okay, so something like that where you show your work and a couple sentences explaining it. So that's function A, where the rate of change is the same as the slope, so the rate of change is 1. So now over here to function B. Function B was a table. And so function B is a graph, actually. And for graphs, we know that the rise over run ratio. So let me show it between these 2 points. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So plus 9 is my rise. And how many units is it over? Let's see. It's 1, 2, 3, 4, 5, 6. So that's a run of 6. So that can be simplified. 9, 6. 3 goes into both of those. So 3 goes into 9 3 times. And 3 goes into 6 2 times. So that's a rate of change of 3/2. So once again, I'm going to do something like I did over here in function A. 2 complete sentences explaining my work. And we know that the rate of change for this function is 3/2, same as the slope. Okay, I'd also add a sentence explaining what I did. And then finally, function C, I'm going to look for the rate of change, the same place as the slope. So I can see here that the slope is the coefficient of x. So in function C, the rate of change is 4/5 because slope is the coefficient of x in a linear equation. That's just my dog barking like he always does. So no big deal there. Okay? So there's my work, there's my explanations, and the question was order from least to greatest. So if we look at all three, 4/5 is the smallest, so function C is the smallest. And then rate of change of 1 is the middle one, and then the largest is 3/2, which is 1 1/2. So that would be the order. Thanks.
Okay, so there's my video. And then here are the two problems that I want you to work through. So problem one is very similar. You want to read the directions carefully. The three friends each get separate part-time jobs to start saving for a new bike. The functions show how much they earn compared to how much they work. Some friends already had some money before they worked. Show all work and explain your reasoning for finding the rate of change for each function. Then rank these functions in order from least to greatest based on the rates of change. An optional challenge is to rank the functions from least to greatest based on their y-intercepts. So that last bit is certainly optional. You can do that if you want to, but you don't have to. So this problem is similar to problem one. So go back and watch that video if you need to, and it will help you explain this problem. Problem two is a little different. They have two students that look at a problem, and they have two different opinions. So problem two is when asked to compare the two functions below by the rates of change, two students came up with two different answers. Riley thought the two functions had the same rate of change because she calculated the slope from the table and got 3/4, which is the same as the slope she got with the graph. Stacy disagreed. She said the function 1 has a greater slope because she calculated the slope as 4/3, which is greater than a slope of 3/4 she got when using the graph for function 2. Explain which student is correct and defend your solution using at least 3 complete sentences. So in this problem, I'm looking for you to decide which student is correct and give a backup. Why did you choose that student? And you might even want to explain, like, what did the other student do wrong? And please do that in at least 3 complete sentences. Okay, so I'm going to end you with a quote because these problems are pretty hard. So work through them. It's only 2 problems, but I'm expecting a lot that you show your work and write sentences. So here's one of my favorite quotes. What comes easy won't last, and what lasts won't come easy. So remember that as you go through these problems. And have a super Thursday, everyone. Bye.